Today we are going to be talking about how to build AI agents or agentic AI systems. So in order to understand what that even means, because AI is kind of like it's like a buzzword. It doesn't really have a technical meaning, but I think right now, what is AI? It's LLMs, it's classification algorithms based on neural nets. It's something that, looks like it behaves intelligently. And what does that even mean? It means it's a system that can make decisions. It can basically, I would say, what artificial intelligence actually is a system that can stand in for a person for a specific job. And maybe on a more fundamental level, it's code that can model how a human being would respond to a certain situation. It's basically an artificial observer, I would say. An artificial observer and an artificial reactor, as in you're reacting to something. Because, what even is a neural net? What even is a large language model? Basically, a very simple way of looking at it, and you guys probably already know this, but it's good to just go over these again. A neural net is something where you have inputs and you're trying to predict outputs. So what do? You have a big data set, right? A bunch of inputs that are correlated to outputs or, connected to outputs, right? Like, let's say I had a data set where, the inputs are 1 and 1 and the output is 2. Okay, interesting. The next input is 2 and 3 and the output is 5. Next is 3 and 3, the output is 6. You and I both know that that's just addition, right? The thing going on in the middle is addition. But the neural net doesn't really know that. So what is it going to do? It's going to train on this, on the data until it builds up a model in this like black box that, can accurately predict the output given the input. So in the beginning, you train it on this data, and what is it going to do? It's going to be, you're going to give it like, what's 2 and 4, and it's going to give you 6. It might be right, but sometime it could do something else, like what's 3 and 4, and it could give you 5. So then if it does that, then you punish the model and you say less of that and more of the other thing. So you change the weights and the model gets more accurate, right? So it's just an iterative process. But what is the model? What's it even based on? It's based on linear regression and nonlinear regression. So that's basically it. So linear regression is basically, inputs and outputs, right? But you plot it on a line, right? So I have a bunch of like data points, right? Like let's just imagine an XY graph. Bunch of data points. If I draw a line through it, that's linear regression. What neural nets do is they add another element to this, right? So you basically have like an activation function. So the most efficient activation function is like, it's either a 0 or a 1. It's like a step function, but anyway, it's glossing over a lot. Basically, the idea there is it's more of a probability that a function turns on or off. That's kind of like what that is, right? You're not baking in like, I guess, a direct kind of, line. You're more baking in like an idea of like, what's the probability that this like, how would you say it? The linear regression like equation that's going to turn on or off, right? So you have an equation, basically, just a linear equation connected to an activation function, that has a probability of turning on or off. Then what? That'll be able to essentially plot something that isn't just linear data. It'll allow you to plot something that has like a weird shape to the data. And then neural nets go one step further by connecting a bunch of layers, right? So you take these two equations, you shove them together, right? And that's like a neuron. And then what do you do is like how many neurons do you stack together, right? So you have like the input, and you feed that to a bunch of these neurons, and they all give a guess, and then you put them back together, and then it spits out an output, an output guess, and you got that, and then you add like layers. So you have like a stack of like 6 neurons. You just add another layer of those, and another layer, and however many you want. And, it can allow you to maybe encode more information, or it really depends on what you're trying to make, if you have like a 100 layer model, with like 100 nodes, and you're trying to solve addition, I mean, that's like a waste of resources. It doesn't really help. When you're building neural nets, it really matters how you actually, how would you say it? Like what your use case is, right? There isn't just like a one size fits all algorithm. But yeah, that's basically what a neural net is. It's a bunch of linear equations connected to nonlinear activation functions. And then, you just layer a bunch of them together, and you got a model, right? And that's all it is. Like, there are, how would you say it? There are other like little tricks, little tricks and interesting methods you can use. Like what I just described is like a deep neural net, but you got other methods like a convolutional neural net. You could do reinforcement learning. You could have supervised reinforcement learning. You could have like a human being kind of helping adjust the weights, rather than having the neural net just like learn itself, right? Because just going back, like all those layers, that neural net is just a model, right? And what it's doing is, taking a guess and then looking at what the actual output is, right? And then if it's a good output, if it's really close to the mark, right, then it's not going to change the model much. But if it's really off, then it's probably going to start changing the weights. And there's some math tricks you can use, like gradient descent, where you see which nodes gave the most impact to the answer, right? And if they got the wrong answer, then you look at the ones that contributed the most to that wrong answer, and you alter them. So yeah, I mean, that's like the power of it, right? You have an input output set of data, and then you can use this just little math tricks to shove a model into it. But it's just it's at the end of the day, all these are just models, right? And the issue with models is they are limited. And one huge issue is if your data set is too small and you really you overtrain to it, like the model will not be able to generalize to other data sets. It's not going to be able to generalize to other situations. But if you have but I would say that like all models to a large extent are like that. Because, all the ideas that will be generated have not been generated yet. All the text that will be written, all the information, useful information that is going to be out there hasn't been made yet. And all of our LLM models we're trained on past data, which means that they're going to be very good at emulating past data, right? Things that people have said or written or whatever in the past. But it's not really going to, genuinely new ideas, genuinely new information. It's not going to be able to like constructively output that because it's not in the model, right? It can maybe pretend to guess something like that, but it's not going to be able to actually genuinely create that because that's not how these things work. At best, the model will be able to connect interesting, disparate ideas. Make a connection that people haven't made. And some people would argue, every new discovery is just a connection. But I would say that that's very much oversimplifying it. Anyway, but that's kind of the math. That's the math of how this stuff works. The math or the model or whatever. Like, what are these systems? That's what those are. And there's not really a magic to it. It's just a model. Now, what OpenAI did when they released the "Attention is all you need" paper is they figured out a way to, instead of just like, they made a very efficient way of creating these models and or modeling like human speech. And I really need to kind of delve deeper in the paper, but from my understanding of the mechanism of the transformer architecture or the attention mechanism is like it's a way of a lot of your words don't matter, but some words matter more than others, some ideas matter more than others. So it's a way of like determining what the most important critical elements of a, how would you say it, of like a sentence is, and then being able to like maintain like a coherent idea of like how the of what actually matters in the data over the course of a sentence or whatnot. And that's butchering it. But ultimately, OpenAI just came up with a better way of modeling, and generating a useful model. So now we have LLMs that kind of sound like people and can output some useful stuff. Now, the popular idea in like the finance world is that these are gonna create AGI. It's gonna replace human jobs. It's gonna do crazy stuff. But that's not. It's like misunderstanding what this actually is. This isn't some intelligence. This isn't some, oh my gosh, it's a sentient being. It's a model. It's a model, and it's going to be very disruptive, but not in the ways that non-technical finance bros are saying. So how do you actually make these things useful? How do you make a LLM useful? Or some other model, right? Some sort of vision model, right? Something that is a classification algorithm that, where they fed it a bunch of images and it outputs, a good idea of what it thinks the image is, right? Or the reverse, you put in a bunch of text and it outputs a cool image. Right. What's the point of those, right? Because a lot of people, they think we're going to replace workers. We're going to have it make art. AI art, I think there's a lot of cool stuff that's been done there, but like the only people who have been like really doing a good job at this are like they have an entire system they've built, And you can't just stumble on it on accident. You can't just go on Google and say, oh, I'm going to make some art. It's like, no. Like, because people will be able to tell what's AI art and what's not, unless you, it's not even just that. It's like, people will be able to see that it's AI art, but see that there's like a qualitative difference to it, that it's better, right? So there's some value in just the inherent generative ability of these things, right? Like, getting text from LLMs and, generating images. But I'd say the actual economic impact of that might be a lot, it's not going to be like the internet. It's not going to be something extremely explosive. The value of LLMs and other AI systems will be in how they are used in systems, not just by themselves. And that's where we get into AI agents. So, what does it even mean to have an AI agent? What are these things? I would say that it is a system. It doesn't even need to have AI as like the central pillar, but it's a system that operates under like a feedback loop, some sort of state machine where it observes an environment, it reacts to it somehow. It thinks about how it's going to act, and then it acts, right? So observe, and then I'd say, figure out when it needs to, react, like with a wake word, right? Or a trigger, or if the data lines up in a certain way. Or on like just a time step, right? Like every 3 seconds, I'm going to do an LLM call or something like that. So it reacts, it thinks about like what it's going to do, right? Do I respond? Do I use a tool? Do I do this? And then it acts in some way. So what does this mean? What's the point of this? What's the point? A LLM by itself is not going to be able to do this, right? You're not going to be able to just ask ChatGPT, hey, be an agent. It's like, no. What this is like it's a synthesis of, both AI and just basic systems that you build out in like Python or something like that. So where do you put the AI? Where do you put it? I'd say the more you ask of an AI, the worse the response is going to get, right? If I give it like a book of a prompt, it's gonna, and if I say, hey, write me 3 books, 3 books are gonna suck. They're gonna be terrible. And it's the same thing with linear regression. If I were to, if I have a bunch of points and I say, okay, what's the overarching theme with all these points? It's this line I drew, right? But if I find a bunch of other points somewhere else, that line is probably going to be way off from where those other points are. But yeah, that's the problem with linear regression in large context windows. That's basically what it is, right? If I ask a lot of words, like a ton, if I ask it to produce a lot of information, it's not gonna be as good, just given the fact that you're just, how would you say it? You're just running into the same problem as of like a linear equation. But what an AI is good at, what it can do, I'd say fairly accurately, is if you ask it for a tight, short, little bit of information, right? If I say something like, I don't know, what is the, and it's something that's not problem solving, right? So if I were to ask how many R's are in the letters or the word strawberry, right? A lot of models have trouble, doing that. Now, Current models are probably going to be able to answer that just fine because, a lot of people have asked that question. But if you were to ask it some other thing where it needs to be able to look at what it just said, in some complicated method, right? That requires a loop, right? It requires you to, say something, then observe what you said, and then, continue. And like, if you get an AI to do that, it starts, freaking out. It doesn't like that. But if you were to ask it like a question, right? Like something you would ask a person, like, how are you feeling right now? Right? Something where it's like qualitative, like one word answer, something where or something classifying, right? Like, what's an animal with 4 legs and makes like a woof sound, right? It's going to say dog, right? Easy. But ask it things like that. Even with like a large prompt, it'll probably have a fairly accurate answer. So what does that mean? This is a model that can be used as I said before, a universal, maybe not a universal, but like a stand-in for like a human reactor or observer, right? So for like a vision model, it's already being used like this, right? Like classifying things, right? Where's the car? And you don't even need an AI for this, for many of these things, but regardless, neural net systems are good for this too. But like classifying where a car is, classifying where this is, where that is, blah, blah, blah. Maybe not where, but like what, right? And I'm sure Tesla's trucks do this. They have like the self-driving looks at like different objects, right? That's a fire hydrant. That's a person. Oh, that's a person that's walking here. Da 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 da. And it's not just neural nets, but you use probably other systems, along with that. But like that's one use, right? Another use could be like, let's say, I don't know, like an auto grader. Like an auto grader would be a good idea or a good example, right? You could say, rank this poem, like on a scale of 1 to 10 or something like that. Or maybe that's a little too quantitative because the problem is these AIs have I don't know, they have biases in how they respond towards judgment call things, because you have to understand the way that these things are trained is, they use like human reinforcement learning. So, people judge the outputs of the prompts, right? When it's in like training, they say this is a good response, this is a bad response, this is a good response, bad response, blah blah blah. And when you are building a model that's catered toward human preference, right? What do humans like? Humans like it when you say their stuff is good. Humans like it when you praise them. So the likelihood, like AIs are biased towards, agreeing with you. They're biased towards, ranking things more positive than negative. So a lot of AIs just have an issue with being honest in that dimension. So anyway, like the problem is with current LLMs, there's just a lot of like different little issues. But the specific use case I want to talk about is agents. Like, how do you get a LLM to act as an agent for you? And use the LLM as like the core source of power of like an agent, right? It's not just like some little tool that like responds to emails for you. It's something that actually runs your thing, like runs your system, or is like a main part of it. And I would say this is the architecture. So you put it out in some environment, right? And you have a bunch of data coming in, right? Like, let's say you put it into an email, like it's you got an email agent or something like that. And you have it manually programmed that every single time an email comes in, you need to like do a start up the program, put it into state 1, right? What's state 1? Read the email and come up with a verdict, right? So you get a big old email and you say, what do you want to do? You ask the AI, what do you want to do? But you also ask, or you also tell it, these are the things you can do, right? Like it's like a fallout menu. You can do this, 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 or this. Or you can just, respond. And what are all these options? These options are tools that the agent can use, right? Like the email says, I want a refund, your products are terrible. And the tools are launch nukes, run a refund algorithm, clean dishes, or respond, and you could say, okay, you could basically prompt the LLM, here's the email that's saying I want a refund. Respond only with the name of, the tool that you want to use to make a decision. So what does it do? What does it do? It ends up responding with a tool name, right? And maybe the tool name it responds with is, what do you call it? Refund algorithm. Or maybe another tool it responds with is response. So, it sends a response and doesn't do anything else. But the most likely thing it'll do is the refund algorithm, right? So then what's the refund algorithm, right? You don't need that LLM anymore, right? It did the job, right? It classified something. It made a decision, like a human would, right? It makes the decision. Now you're in the refund algorithm. And what's the refund algorithm? It's just a little AI system, right? So look at the email. You ask an LLM to craft a response, and then maybe you have another LLM that looks at the response it crafted and tweaks it or something like that. And then you have some program that sends the email. Or maybe you have a human in the loop, right? And it only sends the email if a human being presses check, or something like that. But yeah, that's essentially, I'd say, basically what an agent would do, right? There's something that prompts it to act, right? Either it's a time step or some environmental thing, or who knows. And then the agent is just going to give a guess, make a judgment call on what it should do given a limited set of predefined tools or actions or whatever. And then you have that tool run, that whatever that algorithm is, you run that, and then you go back to the start. You're either looking for new information, or you're waiting to see what happened after you used the tool. And this is like a basic way of building an agent, but it's probably a lot better than what a lot of people what they think the capabilities of this are. And here's the thing. This is a simple architecture, but I feel like you could really make it go crazy. You could really do some big things with it if you just added a ton of tools, or if you didn't just have one agent, you had a swarm of them. And ultimately, look at how a human being kind of acts and reacts to things, right? you know, you're looking at your email and an email pops up. It's from your boss. The boss says, I need to see you in my office right now. You know, you have a number of different actions that you could do. You know, you could respond, like an angry response. Use the angry response tool. Use the understood, I'll be right over tool. Use the pick up your feet and just start walking tool. I don't know, let's say you decide to just pick up your feet and start walking, right? Are you consciously deciding every single little muscle movement? Are you consciously, you know, moving, you know, ATP to your muscles and, you know, are you controlling every cell? No. Almost everything that you're doing is unconscious, right? You have, you know, some unconscious reptile part of your brain that's like, you know, coordinating all your muscle movements and whatever. You got like some interesting, you know, probably, you know, neural stabilization algorithm that's making sure you don't fall over, right? You know, you're coordinating yourself. And it's not conscious, right? It's just happening, right? So it's like the LLM agent, you're right? The LLM didn't really do anything. It just made a decision. And, you know, most of the actions are like just pre-programmed. You know, it's just already done. And if you look at the current language models, they have a variation of this that's kind of interesting. They, instead of having a bunch of just like pre-programmed tools, if you ask it like a complicated question, right? Like figure out how many days until da 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 or whatever. The answer, like if it's like an answer that requires reasoning or math or something like that, sometimes you'll see it literally come up with some code, run the code, and then use that to solve your problem. So how did it do that? Did one LLM do that? No, it's a system of LLMs. What you probably have is the first LLM just trying to answer and then uses a tool, right? It says, oh shoot, I need to use I need to use a tool for this, right? So the tool is like the generate code and run tool, right? So then it generates the code and it runs it, and then you get an output. And it says, oh shoot, okay, this is the output. Let me put that into the prompt response or something. Now there's probably some other elements with like chain of thought and whatever, which I've heard is just kind of like an overhyped marketing thing, but there's probably some value to chain of thought. Anyway, that's what that is, right? An LLM decides to use a tool, decides to, you know, have a Python compiler solve the problem for it instead of it, you know, taking a guess itself. But like anyway, if you're trying to build an agent yourself, I think that's the design philosophy you should have, right? Use it as an observer. Use it as something that makes a decision, right? Use it as something that, you know, takes something really complex and simplifies it into one word. If you want an AI process to be somewhat deterministic, to be something that's predictable, that's not, you know, that's not something that's gonna like lead you off in some weird hallucination route, that's the way to do it. Like that's a scalable model for future AI infrastructure. It's not have an AI just automatically respond to your emails. It's build a system where an LLM can decide how a set of tools are used. And I mean, that's already what's happening. But if you're going to get ahead of the game, if you're going to start your own company, if you're going to, you know, do this yourself, you should know, like on a deeper level, like what are we actually doing here? Right? What are these AIs? It's not something that's just going to, you know, an LLM is not going to work on itself. You're going to need to design some systems around it. Don't get me wrong, these models are great. But you just need to know where they're actually going to be needed to be used. But anyway, yeah, I don't know, if a lot of people are kind of worried about AI is going to take my jobs, AI is going to do this, in many cases, perhaps. But I say human beings are the best at kind of long reasoning cycles, right? You maintain context for your entire life, but these artificial intelligences, they're not as good at that, at the very minimum. And I would say they aren't good at coming up with genuinely new information. So I would say a lot of people think or what do you call it? The entire idea of like artificial superintelligence and some sort of, I don't know, apocalyptic scenario with that. I think that a lot of it's just like a Marvel Cinematic Universe type thing. And I think a lot of the capabilities of these artificial intelligences come from the systems we build around them. That's what I'm trying to say. I don't think it's possible for one of these AIs to just for you to build it and then for it to just be able to do anything. Like a human being is able to universally, a person can probably do anything, right? Like if I wanted to move a mountain, I could do that. If I really needed to, I could, right? I just blow it up with a bunch of dynamite, get a bunch of workers to shift it over a couple meters, or use dump trucks, or I could do something like that. Human beings can get into orbit. We can go to the moon. We can do all these things. But for a LLM or some sort of AI or whatever, is it able to is it a general purpose problem solver? Is it able to do anything and come up with completely new ideas, right? And then continue to exert will on the world, right? Not just make tiny little non-decisions, right? A decision an ant could make, right? Is it able to make tasteful decisions by actually understanding what's going on? David Deutsch, who's a physicist, and who I think he talked about this a bit. He basically says that human qualia and consciousness. Forgot the exact words that he used or the specific concept, but it was basically there's a our power, and I think Penrose also talked about this. But our power comes from our ability to not just see and react to stuff, but to know what's going on, right? To actually understand it, because understanding and knowledge of something, it's not just something that's purely computational, because a model is just an input output. It's a black box. It's just a bunch of relations, and those relations are inherently digital, right? If I you're gonna find kind of discontinuities. You're gonna find weird, if you put an edge case in, it's not gonna be accurate. But with a fully formed understanding of something, it's much more analog. It's a smoother path. There's no there's no bumpiness to it, right? Because you see it for what it is, right? How do you react to that? That can be imperfect, but the way that I think he described it is parrot speech versus human speech. Because with a parrot, you can make a sound once or twice, and then it'll be able to repeat it pretty much exactly. But that's not how human beings operate. I could teach someone a concept, and I ask them to repeat it back to me, and they're not gonna be able to do it, right? Because you're not just mimicking, you're not just a basic model for spitting out something that you're not regurgitating, like a tape recorder thing. In a way, you can make the argument that you're just building a model in your head. But the main issue, and this is just with like current algorithms, but like, do I need to eat up the entire internet and all written human words to like be able to speak English? No, I could speak English after like a couple of years of being alive and listening to like my parents talk. Can an LLM do that? No. So at minimum, the human brain has like way more training power. It's way more efficient. It's way more compact. But I would argue that it goes even further. Like these models are missing something. They're missing some essential elements that biological consciousness has. That will make it so that I think that there's never going to be a case where the artificial intelligences are just going to be able to like dominate us, because they're going to be missing a lot, right? Even if you had like, this is like the current, I guess, path to actual AGI. You have the model I described, right, with a bunch of tools it can do, and it also has the ability to just like build its own tool, right? So instead of having to rely on like the write essay tool, the use calculator tool, this tool, that tool, it'll be able to build its own tool in like Python or something. Maybe it has like Cursor or some other little like coding agent, like build up an entire tool for itself using some input output protocols, and then it's able to just like use tools like that, right? Build me a trading algorithm, right? Like, let's say I ask this agent, find a way to make me a bunch of money, right? And it says, I don't know. How do I respond to this, right? What's my first action? First action, come up with a plan. It comes up with a plan, right? And then it goes back to the step one. Okay, now what do I do? Okay, I have this plan. Let me use a coding algorithm to build, the money-making thing. And it does that. And now it has that running. Maybe it'll figure something else out, right? And I feel like, maybe there's a way to generate generalizable tools. But still, it won't be able to generate a genuinely new idea. So, realistically, just given this model, the only solution for like a really genuine AGI is a artificial intelligence agent that has like the general tool maker thing, right? Some Python code that can make its own tool reliably. But you also have humans in the loop. So maybe you have like some person that the AI asks questions to. It says, hey, figure this out for me. Hey, solve this problem. Or maybe teams of people. And but then we're just going back to how the economy already works. The economy is basically that. A business is basically that. A government is basically that. So if you're worried about AGI, it's like we already have it, right? We already have corporations. We already have governments. But I don't know, a LLM powered AGI. That's probably how it would have to be, unless there's some crazy new math where You know, these computers can come up with something genuinely new. What I just described is probably going to work, right? And maybe it's the brute force solution, but I don't know. I think regardless, if we keep going the current route, you know, it's just going to be a law of diminishing returns. Like, you're not really going to get a ton out of this. You know, maybe just some more accuracy. Maybe it'll be able to, you know, solve code better or something like that. But I don't know. Like the AI, the LLMs are already good. They're already good enough. Now is the time to start putting it into systems that solve actual problems, that do real work. There's probably an entire business idea, business model for creating a way to either build tools for agents or LLMs, or create like the protocols, like some sort of standard protocol that all LLMs can use to incorporate this architecture, or connect tools to LLMs or something like that. I think we're still in the Wild West of how we integrate this, but I think the next couple of years are going to be all about systems integration of AI and how do we do that. And I mean, if you guys are entrepreneurs, that might be an area to explore. I don't know. All the opportunities aren't gone. I think now is a great time to get in the space, but just know where you're supposed to actually get in, right? Don't do what everyone else is doing. You need to understand what this technology actually is, and then figure out, well, what's not being addressed? What are we not doing? And I don't know. This is at least one way to think about it. But anyway, I hope you guys enjoyed. Let me know what other videos I should talk about, or topics I should talk about. And I will see you guys in the next one. Peace out.